All right. So we're learning how to do operations with radicals, which it looks really bad at the start. Once you see an example, though, you'd be like, oh, this is way easier than I thought it would be. So really, the only thing you need to know about adding and subtracting radicals is what you can and cannot do. So the only radicals we can actually combine are ones that have the exact same radicand, or the number under the radical, and the same index. So like the square root of 8, the index would be 2. So we can actually combine the square root of 8 and the square root of 8. We can put those together. So if I have 2 times square root of 8 plus, and then this coefficient, since we don't see a number here, would just be a 1 there. So we have 2 square roots of 8 plus 1 square root of 8. That we can combine together and say that is 3 times the square root of 8 plus, and then we bring down this square root of 2. So we cannot combine these two because the square root of 2, square root of 8, those are separate things. So I can't combine them as is, but I can look to simplify the square root of 8. So square root of 8 is the square root of 4 times the square root of 2, and we know that the square root of 4 is 2. So if I combine all these together, so 3 times 2 is 6, and then 6 times the square root of 2, right? So 3 times square root of 8 is equivalent to 6 times square root of 2. I can bring this one down. And now we see we have the same number under the radical, square root of 2, square root of 2, so I can add these together now. So 1 square root of 2 plus 6 square roots of 2 is 7 square roots of 2. And there you go. So what this comes down to is you combine any radicals that you can, and then we simplify from there, and then we try to combine again. Okay? So one other example that we didn't see there, and it's not in the other example, is what if our problem was the square root of 2 plus the cube root of 2? So these ones, they have the same radicand, same number under the radical, but they have a different index, okay? Which means you cannot simplify this. You can't combine these together. If it said simplify square root of 2 plus the cube root of 2, your answer would be the square root of 2 plus the cube root of 2. There's nothing more you can do with that. So the only time you can add or subtract is you need the same number under the radical and the same index. Okay. Let's look at one more example. So I see negative 2 square roots of 8, negative 2 square roots of 8, so I can combine these together. So negative 2 minus 2 more is negative 4 square root of 8 plus 2 times the square root of 12. Okay, so then I can simplify these. I just did the square root of 8. I know that comes out to 2 times the square root of 2. And that's always going to be true. You might want to just write that down somewhere, that the square root of 8 is 2 times square root of 2. That changed colors just like that. I didn't press anything. I just wrote it changed colors for one number. How bizarre. Okay. Then the square root of 12, well, this is the square root of 4 times the square root of 3. Square root of 4 is still 2. So the square root of 12, I would write this one down as well, is 2 times the square root of 3. Didn't change colors that time. Smartboard is a mystery to me. Okay, so let's see. If I combine all this together now, on the left-hand side, negative 4 times 2 is negative 8. So this becomes, actually, bring this down more. This becomes negative 8 square root of 2 plus, and then I've got 2 times the square root of 3, so that's 4 times the square root of 3. Okay, so what am I left with? So negative 8 square root of 2 plus 4 times square root of 3. These have a different number under the radical. I cannot combine this any further. I can't simplify my square roots any more than that. So I'm going to leave my answer just the way it is. If you wanted to get super fancy, I don't even know if that works, if you could actually factor something out here. Don't worry about it. Leave it as is. okay? If you have different numbers under the square roots, they're always going to be separate terms. Just leave it, just make sure you check you got the right coefficients, you're good to go, okay? The other way you could do this, if you're so inclined, is instead of combining your square roots of 8s, you could simplify all of your square roots first, and then just collect all your like terms at the end. You would get the same answer. That's actually what I did the first time I went through these problems to check my answer key. So I don't know, that might work better for you. I kind of like this way that we showed. I think it's a little bit faster. I would definitely write down what the square root of 8 and the square root of 12 are. That will help you out. Hopefully this is not too difficult. I think this is a lot. Well, not a lot. It's a little bit easier than what we did Monday and Tuesday. So good luck. Let me know if you have any questions.